Hello, hello. Can you hear me? Can you see me? Everything seems to be turned on, so I hope you can. Nice. NHP has been there from the very beginning. Welcome, welcome everybody. I'll be right back. Hello, hello. Are we on time? 12:30, right? Yeah. Samsa, welcome, welcome. Legger, welcome. Polar Dark. I'm gonna have a hard time pronouncing all these names. Freddy, that's an easy one. Hello, hello. Ludek. Jägermeister. It's not a real name, is it? All right. Well, I hope to have a fun little one today because I did a little preparation. And here is the framework desktop, but not really the desktop. It's more like the framework parts. And today was the release of these. Actually, I don't know if they're released yet or not. Does anybody know if these are released yet? If they're on the website? I don't think they are. I think that is just the embargo lifted today and people can now talk about these. But if you caught my video from the previous time, there was a little bit of a blacked out or blurred out area. Well, I'm going to share some of those numbers today because I couldn't then, but now I can. But first, I'm going to show you this thing because so I've been building my own systems lately. I've gotten into it. You know, I've been using Macs for the last, I don't know, 12 years. Before that, I was a PC builder and I used to build PCs, but now I'm getting back into it because AI. So I've started doing these kinds of things, and to do these things, you need to build PCs. Well, what I'm getting to is out of the 1, 2, 3, 4, 5 PCs that I recently built, this was probably the easiest thing I've ever put together, and it's actually it surprised me how quiet and powerful this thing is, and it's totally worth the wait. This is probably one of the later things that came out based on this chip. This is the Ryzen Al Max Plus 395. However, I think it's definitely worth it. Now, if you caught my video about this thing, this was the first computer to have that chip in it, the first desktop. There was also a laptop by Asus, but this was the first kind of mini PC that had it. And it works pretty well, but it's loud. So when I got the framework one, I was kind of expecting the same thing, the same kind of experience. No. I was blown away by how quiet it is. In fact, most of the time I'm just using the machine, the fan doesn't even spin up at all. It just sits there. Only under really heavy load, the fan spins up. Anyway, it's my little secret. And you're wondering, why do I have these brand new ones here? And I already know how this thing operates and works and how it behaves. It's because back in January when Framework first showed their cluster at CES, I got in touch with them. I was like, hey, that cluster looks pretty cool. You know, I test clusters on the channel, so hook me up. I can show it off on the channel. And they said, okay, we'll get back to you. We'll see. And months went by, and they finally sent me 4 of these things. These are boards. And I think that this is the way to go. I mean, yes, the desktop version gives you a little bit more features. There's the little pluggable components to it where you can do the quick expansion. But other than that, this gives you more flexibility. So I'm working on a couple videos about that. I'm working on a video on the flexibility aspect of it. I'm not going to say more right now. I'm also working on a cluster video, but I'm slow. It takes me a little bit longer than Jeff to do this stuff. All right. Plus, trying to iron out a bunch of little details about the cluster situation. It's a work in progress, just like you might have caught Jeff Geerling's video this morning. But let's put this thing together, and what I'm going to do today is show you how quick this thing comes together, hopefully. So let me see here. I got to turn on a couple things here. Can you see that? Oh, you can't see that. You know what? Let me do this. This one should be multi-view, so I can see the whole thing. Camera 8. There we go. Sorry if it's upside down, folks. I haven't been able to fix that yet. Here are the parts. We got the main board, which is really freaking easy. Let me okay. Let me show you this. This is how easy it is to get in here. There's the main board. Boom, done. We've got the power supply. Also a rippable package. I love that. That's like really nice. Don't need that. Here is the power supply. It's 400 watts. It's very small, so it does produce quite a bit of heat. But there is a way to manage it, and they provide this little pipe thing on the end to kind of manage the heat. You're supposed to be able to pump cold air into there, or cool air. It's the intake, and it goes through there. There's a little fan that pulls the air in and blows the hot air out here. So if you, I think on the desktop version of this thing actually points, the pipe points outward. Is it too dark? I don't know. I can't tell. The pipe points outward of the computer, and that's a good position to have it in. In the cluster, though, it's kind of sitting like that, where this thing is pointed up, so that's not great, and I'm working on something for that. You can actually remove this part as well and just have it blow straight through. That might be a better approach. I think that's what Jeff did. Power supply. Also, this cable is really short. It's designed to fit in the, in the framework desktop, and it'll work. What is going on here? What am I doing? It'll work in some cases, and some micro ATX cases as well. This is a standard micro ATX size board. However, you want to make sure that your power supply is going to sit on this side of the motherboard, like that. If it sits on this side, obviously that cable is not going to reach. What else we got here? This is, by the way, like what they sent me, so it's probably the recommended approach. This is the Western Digital Black Terabyte. Of course, you can probably use whatever. This speed right here, I measured the speed on this, and it's very close to that, and that is amazing. It's close to what the MacBook Pro that I have comes to. You can use whatever SSD you want, I'm pretty sure, but this is the one they sent me. So there it is. And we got a fan. Now you can use whatever fan. This is 120 millimeters standard cooler fan for the CPU, for the APU cooler. All right, they give you this little shroud. They give you the screws. And they give you a Noctua fan. This fan is really well designed, and it's one of the reasons why this machine is so quiet. Because when the fan is on, it's still barely audible. Really nice. So that goes there, right on top, and you want to make sure that you're putting that right where the APU fan header is. So probably facing this way, it just pops right on there. You don't need to mess around with putting the CPU or the chip onto the board. That's done for you. And that's why I think this is a really nice little package. It's really easy, as I'm having a hard time putting this fan on. It's just a matter of aligning these. It's really tight, but it's nice. All right, and then you just pop this in here, this header, just like that. Fan is connected. Now, here is the best part. This is my favorite part. Maybe I'll get another light in here so it's better to see. This right here is the SSD, and there's another one on the back. So it's really easy to pop this in. And in fact, if you don't want that, you can remove it, that part right there, if you're not going to be using that, because it does stick out from the bottom a little bit. Now, I also did my own little upgrade, and I got a button. It's just a little cheap button on Amazon. So you can just plug that in. This ridiculously long cable they gave me, I can put this across the room probably. And this goes in a standard location where the buttons are right here. Power, LED. All right. Now let me show you how easy it is to get to this SSD, and this is my favorite part. So you're going to be using a T5, just like that. So this is the heatsink, and everything's already mounted and it's spring loaded. So all you do is pop that in there. But I'm going to cheat because I don't want to have you all sit through watching installing the operating system, because I already have a little bit of a setup. So what I did was I installed Windows, dual booted with Linux, Fedora 42. And I already have a bunch of software on there. So hopefully, if we have enough time, we can do all that. Now you can start voting in the, maybe I should do a little poll or something. What do we want to test first? Because I know you're all here for some LLM stuff, probably, not gaming, right? Yeah, the motherboard costs $1,600. No power supply or SSD, just the APU and RAM. So somebody's saying fan is backwards, but oh, thank you. Yes, I did put the fan on backwards. I'm gonna have to redo that, but good thing I didn't screw that in yet. All right, here's the one in the rack. it's good to pay attention to chat once in a while so people can help me out. So I'm gonna pop this out just like that. Really easy. Let's put that aside. Done. SSD installed. Let's just flip this fan upside down. Thanks to all those people paying attention in the chat. I'll probably not make just this mistake today. There'll probably be more. But overall, that was pretty easy, right? All we need to do is just pop this power connection here for the motherboard and the CPU. And we should be able to power it on. They gave me a cable, but I already have one here. Might as well. You know what? Let me get a power meter too so we can monitor that. All right. Nice. So that just goes in there. The power button goes on. Wait. Am I gonna need to screw this fan down? I probably should. Kind of like wearing a seatbelt on the bus, you know? It's not gonna fly away or anything, but you know what? I'll do that later. Screw it. And screw it was not meant to be a pun, but it turned out to be that way. What is chat saying? Wow, I'm far behind. There's an OpenAI live stream today, and I started. Well, there's. Oh my God, is that the release of? Is that gonna be GPT-5? It better be not. Better be not. Because I don't think we're going to get to... Well, let's see if we can get to it quickly. GPT-5 release. That's just your guesses. Your guess is as good as mine. All right, let's plug this thing in. I'm going to just pop in a mouse, pop in a keyboard, pop in a monitor. Good. We're ready to go. Let's turn this thing on with this button. There we go. $40 watts so far. Oh yeah. First time you turn it on takes a little bit, a couple minutes to warm up. What do we got here? Here it is. It's coming. It's coming to life, folks. Do I have output here? No? Come on. We need to be able to see the screen. Oh yeah, I do. It's just really dark right now. Oh, look at that. Now in the real world, you're gonna have to install that, and that might take, it's Windows, you know, it takes a few minutes. Is that in focus? Can everybody see that? I think we're gonna start with Windows and then move on from there. It's dark? This is dark, really? You're right. You're right. Chat is amazing because you guys keep me on track. There we go. How's that? Better? The pin is no longer available, and that's because Microsoft security stuff. So let me fix that real quick, because that's a pain. You'll need internet for that. Of course. Of course. I forgot the Ethernet cable. All right. Good focus, but dark. Perfect. Oh, it's Windows. You know, I have Fedora on this. Maybe we should do a little vote to see what people want to see. How do I do that? Let's do a little poll. You see the poll? Maybe I don't need to bother with the Windows setup. People use Windows. A lot of people use Windows. All right. Linux is just a minority of the users out there. I gotta set up this pin while we're here, and then we'll switch. It looks like most people want to see Fedora anyway. Hey, that's cute. Got a little bit of a rat there on the screen. Look at that beautiful rat. Two of them even. You know what? Since we're here, I'm going to do just one thing. Just one thing. Let's do it. All right, we're going to run this one thing. Where is... Got to remember where I plug these things in. So, can you see that? I think you probably can. We've got LM Studio. As you can see, I've been messing around already on this. I have a couple of models, all right. Here is Gemma 4B, and we can GPU offload 34 layers. Let's do a quick one here. Write a paragraph. $49 tokens per second. So it just gives you an idea. Fine. You want to see the other one, Fedora? Let's do that. I'm gonna switch over. Hey, welcome to membership, my own private channel. Thanks for joining as a member. That's pretty cool. I gotta tell you something about this. All right, right now, the fan has not even spun yet. I mean, it spun when I first turned it on, but look at this. This is crazy, right? The fan is not even spinning. This thing runs pretty cool. We're using 13 watts of power right now. I mean, it's an x64 based x86 system, right? It should not be like this. But AMD managed to do this. And finally, Framework with their custom, cooling solution makes it happen. All right, so what are we gonna do here? I gotta say a couple things. One is we're gonna take a look at the GPU, make sure that's working. We have multiple ways of running this. First of all, if you're gonna try Ollama, unfortunately it does not work, so I'm just gonna skip over that altogether. For some reason, after installing and reinstalling Ollama, it's just not using the GPU. It only runs on the CPU, which is kind of unfortunate. LM Studio has pretty good support though. If we take a look at hardware, you'll see that it's detecting the Radeon 8060S. Can you see that, or is it too far? I want to be able to use the camera because I don't want to share the desktop. That's gonna mess with the graphics and all that, so let's do this. I'm gonna move in a little bit closer. Hopefully that'll help out. That should be a little bit better. All right. VRAM is showing as 78. Now, I'm not 100% sure how the VRAM is allocated and how LM Studio is detecting the VRAM. Because here, under the system monitor, is showing that 512 megabytes are allocated to the iGPU, which is the default. Now you can go into the BIOS and adjust that, and I'm still working out whether that makes a difference or not. Because in my tests on the other machine, the GMK Tech machine, it did make a difference whether this was set to auto or not. Or you can hard code or pre-select the amount of VRAM you want. You can select different discrete values, like 1 gigabyte for the iGPU, 2, 8, 30, 16, 32, 64, up to 96. And I found that from my testing, I found 64 is a good sweet spot. But I need to do more testing on this machine to see if anything's changed since I did the GMK Tech machine test. So we'll see. All right, let's, it looks like the YouTube video is way behind where I am. So I'm looking at the preview and it's like, wow, we did that a few minutes ago. Let's take a look at runtime. Runtime, I've got ROCm installed and I've got Vulkan installed. Now, I'm gonna show you both of them, but ROCm is rocky. Vulkan works much better, just to put it bluntly. Let me show you. Okay, so let's select ROCm, okay? I'm gonna show you that first because yeah, there is support for it and they're working on it, right? They're working on it, but it's not great. Let's take a look at I don't know, Gemma 34B, because that's what we did on Windows and we got 48 tokens per second there. So let's see what it gives us here. So we have some kind of comparison. Write a paragraph, if I could spell. This message contains no content. Failed to send message. The model crashed without additional information. Oh my goodness. Huh. Maybe it didn't like my spelling. Nope. It's crashing. That's not good. So that was Rock'em. It's not happy. Now, it doesn't mean Rock'em doesn't work. It works. Maybe we'll try a different model to see if it works on a different model. Let's do OpenAI GPT OSS 20B. Let's try that one. Nope, failed to load the model. So, not an impressive start so far. But let's switch over to Vulkan. This better work, I'm telling you. Like, these people came to see this. And work with me here. Look at that, 64 tokens per second for Gemma 3.4b. Way faster than on Windows. Now, let's switch to a different model. Let's go to 20B. That's the new OpenAI's GPT OSS 20B. And load that model up. And take a look at this. It's going into shared memory, but it should be going into the GPU memory. Not sure what's going on with that. Write a paragraph. Boom. Okay, so that was 60 tokens per second. 60 tokens per second is really nice. And look, that happened on the GPU. 100% GPU utilization happened there. The memory usage here is not showing very, it has 512 megabytes total to work with, so it's not going to be showing you more than that in this particular row right here. So it's using that as shared memory. I have not yet figured out what the balance is and what the best balance is, but that's what we have right now. And if you want me to show you, if we can switch it in the BIOS to a different one, I can do that. Just let me know in the comments or in the chat there. Now we're going to load up OpenAI's GPT OSS 120B. And some of you might think, oh, well, he's just doing these toy context sizes. Yes, we're starting out with that because, unfortunately, the non-toy context size doesn't work for these two models right now. So there's 120B being loaded up. It's taking a little bit of time, but it's done. Check it out. I can say hi to it. I know you all loved my hi prompt. And there it is. It popped up at 41 tokens per second. This is without a discrete GPU, folks. This is just the iGPU. Look, the fan is spinning now, but I can't hear it. Seriously. Like, this is some Mac level shit right here. I'm pretty impressed with this machine. Now, I don't know how it's going to work in the body of the framework, desktop. But out in the wild, out in the open, just like this thing is quiet. And the fan stopped. It was done working, so it stopped. That's how it's supposed to be. Wow. Impressive. Impressive stuff. Framework did a good job this time around. I have too many cameras. All right. So 41 tokens per second. Let me show you what happens, though, if you try to change that and increase the context window, the context length. Let's go to a little bit more. Let's go to 10,000. Still not much, right? I've had problems loading this, though. Hey, maybe now it's going to work, now that everybody's watching. That's always the case, right? When you're doing a demo, things just work. No, it's usually the opposite, but it actually worked this time. Hello. Hey. That worked. 32 tokens per second. So we got knocked down a little bit. And then we got to back up again. Yeah. Never going to keep us down. 59 gigabytes out of 117 being used right now. Not much. we still have headroom. Let's push it up a little bit. 120B and larger context. Let's go to 50,000. Come on. Oh, there it is. It failed. But I kind of expected this to happen earlier. So 120B, 50,000 context fails. And that model is 59 gigabytes in size. What about something else? What about these Qwen 3 coder models, which I've been a fan of lately? So here's Qwen 3 coder 30B, and this one is 30 gigabytes in size. So we can offload everything to the GPU, and we can increase maybe this one to 50,000. I think we should be able to. Let's load that up. $120 context or bust. So yeah, Windows has a different set of drivers right now than Linux. I could try this later in Windows. Maybe I'll mention that in the video that I'm making. And we were able to load this 50,000 context. We're doing 53 tokens per second here. The fan did not even spin up on that one. Let's do a little bit longer. Write a paragraph. There it is, writing a paragraph. The fan? Nope. Didn't even spin up. So this thing is silent. This machine is silent even though it's doing all this. I mean, yeah, I could probably get it to spin up. Write a long story. And let's see how long that takes to get us there. Fan is still stable. It's printing out this whole story on the screen, but the fan is not even moving yet. That's what's insane about this to me. Okay, there it goes. So, you know, you've seen my test maybe on the 5090s and the 5080 up to, you know, whatever. The AMD GPUs. Those fans are constantly spinning and they're loud. To have something like this and to have it be this fast is pretty amazing. 46 tokens per second. There's the GPU action. All right. So somebody says, May says, can you try a dense model more than 20B? So what he means is, or she, I don't know, these models that I've been trying are a mixture of experts. So they only have a few active parameters. Like if you have a 120 billion model, they have like 5 billion active parameters. A dense model would be like this Llama 3.370B. This one is 40 gigabytes. And it's going to have all the active parameters. So I can do full GPU offload. Let's kick this off and see if it loads. I believe it will. All right, I'm afraid to do that, Caven, but we'll try it. We'll try it. All right, let's write a story, okay? So there it goes. It's writing the story. As you can see, it's quite a bit slower. But it's a 70 billion parameter model, Q4. It's using the GPU to the fullest, and it's running. It's decent enough. It's much faster than pretty much everything else we've seen from iGPUs in the past. I'm going to stop it to see the tokens per second. 4.93. Okay, it's not great. So that's 70B. Dense model. let's check out, let's go back to that 120B, and I mean, this thing is not gonna load. I'm not even gonna, all right. To humor you, Kevin, I will go ahead and try to load this. I know it's not gonna load. Watching that progress bar. Hoping. I know it's not gonna happen, but I'm still hopeful. Yeah. Failed to load the model, unfortunately. All right. Does that give you enough kind of a hands-on thing? Because I can go over some of the charts that I did to experiment with this thing. Do 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 do. All right, so I ran this thing. Yeah, let me know if you want to see anything else with that. And if you want to see a difference between like a specific model with Rock'em and Vulcan, we can do head-to-head on that. There is a guy, oh, I should remember his name because I just watched this video yesterday. And you should go check this out too, by the way. Let me see here if I can find him. What's his name? It's in my history on YouTube. He's an Italian guy. He just posted a video on this chip the day before the framework one came out, but I couldn't say anything. But he has a fantastic video that goes into a lot of details. This one right here. Go check this guy out. Donato Capitella. Software engineer and ethical hacker. I don't know why I'm doing the fake Italian accent. It's silly. Excuse me, please, for if anybody is offended. Donato Capitelli. All right, I'm done. But he does have a little bit of an accent. I thought it was more German. Anyway. He has a bunch of videos on his channel, but this last one he did, August 5th. Check this out because he goes into a lot of detail on the differences between the backends, like Llama CPP and how that runs with Vulkan versus the two different types of Vulkan, which I didn't know about. There's one that's official and there's one that's community driven. Maybe I'll link to this in the description there. But he created these toolboxes. You know what? Let's just run that. Why not? Toolbox. Toolbox list. All right, so we've got Rock'em 6.42, Llama Vulkan AMD VLK, and then Llama Vulkan RADV. Now, if I go to Llama directly and run it on my host system, we're going to get slightly different results. So let's do that first. Let me go to, where did I put that? Llama CPP, right. I think here. Okay. Anybody want to see specific results for any model on Llama Bench? Let me know in the comments. Llama Bench, and we're going to pass in a model here. That's not going to work. Let's do this. My models are in a secret place. Who do we got? We got Unsloth. Let's do that one. And GPT-20. So this will give us the prompt processing speed and the token generation speed as the Llama benchmark says. Yeah, Donato Capitella. Everybody go follow him. Really good stuff. So large DeepSeek model is not gonna work until I figure out something about this cluster situation. And Jeff, by the way, has been I've been talking to Jeff Geerling about how his setup is going. So he was able to run it. I don't know if you caught his video this morning, but check that out as well. He was able to run it. However, it's pretty slow, right? So work in progress. Oh, Framework is in the house. Welcome, Framework. You have a nice little piece of gear here. Congratulations on the launch. And we just did the GPT OSS 120B. It works quite well. Wait, is GPT-5 already announced? Did I miss something? Don't go there. Watch this. So what do we got here? We got GPT OSS 20B. We've got 575 and 73 for prompt processing and token generation. That's pretty cool. Let's run Llama Bench on the 120. And we're gonna do that one. All right, let's take a look at this one to see what we get here. So prompt processing 73 for a 20 billion parameter model is pretty incredible. You have to admit that. Can you imagine what kind of chips we're gonna have next year? It's gonna be crazy. $212 for prompt processing. And 47 for a 120 billion parameter model. Now you can also use the toolbox, Donato's toolbox that he created. Let's take a look at that and how does that compare. Basically, we can now pick and choose what framework we want to use as the backend. So we can say, oh, I want to use Llama Vulkan, the AMD version, right? Toolbox, enter that one. Let's see how that one runs. Is this going to remember my Llama Bench command? Maybe not. Let's just copy that and paste it. Let's do the short one. And I think I don't need that. Oops. I can just run it like that. So it's a Docker image. It runs inside Docker, but it's looking at your local models, and it's using the GPU, which is really convenient. Look at that. We've got the AMD Vulkan image giving us 1,000 tokens per second for prompt processing and 71 tokens per second for token generation. Let's do that again. That 1,000 seems sus. No, even higher this time around. Pretty cool. Yeah, wow. And now let's say we want to check out the AMD RAD-V. Now I gotta say that according to Donato, I was gonna call him Donatello. Oops. No. It depends on the model. Every model is going to behave slightly differently. So for some models, ROCm is going to be better. For other models, the AMD version of Vulkan is going to be better. And for other models, the RAD-V, the open version of Vulkan, is going to be better. And now there's even ROCm 7, which is, you know, up and coming. So each one of them is going to be a little different, and you're going to have to pick and choose and try different ones to see which ones work better for you. We've got 73 tokens per second, which is pretty consistent for the other for the other Vulkan. What about what's the other one we have? We've got Rock'em 6.42. Let's try that one. I'm expecting lower numbers here, by the way, because Vulkan has been doing pretty well in my tests. Prompt processing 564, just a tiny bit, you know, smaller, but not that much. 67. Okay, it's a little slower, but not that much. So that's another toolbox you can use to quickly grab other frameworks and compare them for your models. Let's take a look at some of these charts here. So I created a script basically that goes through different prompt sizes for those of you that are interested. I set the context length, you know, not huge, but much more than your default one. 50,000, and I've got a prompt here that's 44,000 tokens. I've got a big prompt here that's 17,000 tokens. We've got 1,200, 2,300, and then smaller ones in the 100 range, and then even smaller ones that are like this, really short ones. And I just wanted to run through all these, and I did them overnight. Like, it takes a while to run through all these, and each one is run 5 times. So let's take a peek at Quencoder 30, because that's probably my most complete one. I totally forgot how to run this thing. So it's do I have what? I don't have a V environment here. I thought I did. I do. Oh. If you don't know what I'm doing, I'm using UV. I set up a little custom environment here so that I can isolate my Python dependencies. I made videos about this earlier. Plot results. Let's pass in the result file. And I want to take a look at, well, I've got a couple of comparison points. I've got this framework one. Let's take a look at that one first. Coder 30. I also ran the Qwen 3 235 billion on this, and it worked. That's a 111 gigabyte model. That doesn't work with Rock'em, but that works with Vulkan, by the way. So let's do Q4, because that's pretty decent at this point. And chart scatter. What? Okay. All right. Here it is. So this is Quencoder 30 billion, and we've got all of them. They all ran. Even the really, really large prompts. Now it says 36,000 tokens. Actually, it's about 44,000, but it depends what kind of tokenizer you're using. So for this charting part, I must have used a different tokenizer. Anyway, it's close enough. So we've got tokens per second is 12. The lowest was 6, but we're all clustered around here. And we're around 12, 12.5. That's pretty good. Here is the second largest prompt, 17,000 tokens. And we're at 23 tokens per second here. 22, 22, 21, the lowest being 18. And then here's the rest of them. These are the smaller ones. Of course, they're going to be much faster. What's this one? This is about 2,300 tokens. And we're about 35 to 39 tokens per second on that one. This is the long programming full project prompt. By the way, I'm going to have all these on my GitHub if you want to check these out, the results. I'm thinking about actually getting these all compiled, putting them up on a website somewhere so that people can dig through them. Hi, Rajat. Nice to see you. Okay, Framework is answering some questions here. Batch 1 starts shipping next week. You're going to be busy. Nice. All right. Framework laptop would be awesome. A Framework laptop with this chip would be really pretty cool, I think. But it would be expensive because AMD charges, from what I understand, an arm and a leg for this chip. I guess it's worth it because what we've seen so far is pretty good performance. So is this so this or Max? Okay. Yeah, I think this desktop is gonna kill. Very hard to get rid of heat in a laptop. Absolutely. I made a video about the 395 in the Asus laptop, and it works. It works well, but I wonder how it does compared to something like this. You know, like an open air board with just the chip, where the power supply is not next to it, warming things up. That power supply is nice and toasty. If there was a way to cool that a little bit better, that would be ideal, because in a desktop, they're going to be sitting like really, really close together, you know? But the fan is not even working. You know, I got to spin it manually. That's crazy. You should be spinning, but you're not. That's pretty cool. Anyway, anybody want to see a comparison with what other tests did I have here? Well, I did a bunch. I have an M4 Pro test and RTX 5090 with the 5060. That's from the video from a few days ago. So if you want to see those charts compared to this, let me know. I mean, they are going to be faster than this. But, well, is the M4 Pro faster? Let's take a look. I'm going to actually do that. What do we got? Let's take a look on this side first. We've got 7 tokens per second, and the highest being 11.2. And the framework? 12.2. 6 being the lowest. Huh. They're pretty close, aren't they? Okay, so for the smaller prompts, you can kind of see, yeah, the chart is actually not static, so yeah, that's not a good way to compare them, jumping back and forth, because the numbers are not aligned. Let's just take a look at one of these. So the green one, medium architecture web app, 106 tokens, very small prompt, 41 tokens on the framework, and 67 on the M4 Pro. So the smaller prompts seem to be a little bit faster on the M4 Pro, and that's the Apple chip, in case you're wondering what I'm talking about. Let's take a look at this pink one. On the framework, this is the long programming full project prompt, which is 2,300 tokens, 39 tokens per second on the framework. And the fastest the M4 Pro did this was 63. And what about over here? This is the extra long programming code heavy prompt with 17,000 tokens. On the framework, we've got 23 tokens per second. On the M4 Pro, between 24 and 29 tokens per second. So when it comes to really long prompts, the framework one is kind of winning here. When it comes to really short prompts, the M4 Pro wins. Interesting stuff. I love these kinds of charts. Just like visual, makes you discover stuff that you didn't see before. All right, so Mark asks a pretty good question. We're at 14 watts right now on this unit, but let me run a prompt and see where the power goes. Let's do this one. Quencoder 30B. Write a story. You know what? I have these prompts here. Why don't I just use one of them? Let's do this one. Let's do this prompt right here, which is like in the middle, 2,300. Paste. That is a big prompt. You're not writing that by hand. Okay, let's push that out there. It's working. Processing prompt. Okay, we don't usually see that with my high prompts or write a story prompts. There it goes. It's doing it. What do we got on the power usage? Power usage. $148. Still going. So yeah, that looks like pretty stable at 148, around there. Fan. Obviously, the fan is working now. Oh, I'm starting to hear it a little bit. It's spinning faster. Still going. I mean, this thing is a big prompt. It takes a while to print out the result too. But yeah, that's pretty good power usage, about 150 watts. And the GPU is, wow, look at that GPU utilization. 100%. Okay. Yeah, the M4 Pro, I should say, does not even come with 128 gigabytes, just to clear that up. It comes with 64. Well, we're at 48 tokens per second on that prompt, and it's done. Power mode is set to performance. Somebody asked that. Amstan. Anyway, I think this is a win. I consider this a win. Now you got to also look at it not from a point of view of what this thing is capable of, because obviously it's really, really capable. But also the pricing. The pricing is, it's not cheap. That's all I can say. It's $1,600 for this right here, this board. And it's, I think, $2,000 for the whole framework desktop if you buy the whole thing. It's not cheap. But 128 gigabytes? Now compare that to what else is available with 128 gigabytes. There's the M4 Max. How much is that? That's a lot. Let's take a look at that. That's, I mean, if we're going to be looking at a Mac Studio with an M4 Max chip in it, that's $2,000. And that's the smaller one with the 16-core neural engine, 14-core CPU. By the way, we haven't even done CPU tests on this. This is just like LLM and GPU stuff, because this thing has, can I split this up? Yeah, look at this. Look how many cores this thing has, or threads. That's crazy. Wait, are you seeing me right now? You should be seeing the screen. What am I doing? What kind of live streamer does that? A silly one. Look at this. The multi-core score on this thing is probably really high. I believe it was around 20,000 for Geekbench. Around there somewhere. Anyway, that's really nice. Mac Studio costs $2,000 to get started, and that's with, let's take a look at how much RAM they give you. 36 gigabytes of unified memory. Not even not even 128. Let's bump that up until we are able to get 128, and now we're at 3,500 all of a sudden. And how much SSD is that? 512. So if we bump that up to 1 terabyte SSD, we're at $36.99. I mean, it's Apple, right? It's going to be really, really expensive. But NVIDIA is even more expensive. For 128 gigabyte DGX Spark, that's not even out yet. Still waiting on that one. I'm going to test that thing as soon as I get it in here. That one is $4,000 now. They said it was going to be 3, I think, when they announced it. Now it's 4. So, yeah. That's crazy. Now, you also have to weigh CUDA, right? CUDA is a very popular platform to develop for. And that's what NVIDIA does. There's a lot of stuff out there for CUDA. AMD, a little bit of a setup. Vulkan is really good, as you can see. Rockham needs a little bit more work. But CUDA is pretty well established at this point. What are you guys saying here? Oh, the M4 Pro, I don't think it can be spec'd with 128. Yeah, the M4 Pro cuts out at just 64 gigabytes. Just 64. 64 pretty good, but you don't get more than that. Let me do a little poll here. I'm really curious about this. I gotta close my previous poll. Start a poll. All right. Um, is 2K a good price for 128 gigabyte machine like this? Let's see what people think here. Yes. Yes. Yes is going down a little bit. Yes is going down. All right. Seems like the yeses have it. I mean, obviously we want to have it cheaper. We always do. But given the landscape of what's available out there right now and what the capabilities of this thing are, I think that's a good spot to be in. Especially if you get just the board and do your own things. You can just get the board for $1,600. Then I think you need to add the fan yourself. And if you're buying a separate case, I had one somewhere. Anyway, just a sneak peek. If you're buying a separate case like this, you can save some money. Sneak peek. For those of you that stuck around. All right. I think that's going to wrap it up today, folks. I don't know. Can we get a CPU test on this model? I think I'm going to do that, just probably not right now. We're going to leave that for another time. Maybe I'll add that into the video. All right. This has been fun. It's been fun hanging out again. I don't do these very often, but it's nice to interact with you folks. The GMK Tech Evo, yeah, thank you for that. I also didn't mention that one. The pricing on that one is also 2Gs. This machine right here. I mean, it still has the same chip in there, but the design of everything else is a little bit different. And you might want to keep this in a different room because it's loud. That's really the only downside I have about this machine. It's really, really loud. And that's what really impresses me about that framework design. But it does have an SD card reader. So that's pretty cool. I was thinking about painting this, like taking it apart and painting it. I'm not sure. I think we're going to wrap it up, folks. Thanks for coming. It's been fun. Till next time. See ya. That camera. Bye.